So in addition to compounds having formulas, they also have names. And the most common example that you might be familiar with is table salt. All right, its formula is NaCl, but its name is sodium chloride. So in this video, we're going to talk about the rules governing how to name the common chemical formulas, names. All right, a common rule that's going to, or a common theme that's going to exist in this section is that one name should only have one corresponding formula. All right. So as a little bit of an analogy, I'm going to just ask a very simple question: how old is George Bush? All right. And if I were to ask that, the first question that people would generally ask me is, which one are you talking about? All right. And at the time that there was only the first president, he only went by one name, George Bush. It was only after his son became president that people started having to include a middle initial, and that's because of a fundamental problem. If you just said George Bush, it could refer to two separate people. And so we needed some way to distinguish between the two, and so people started the convention of including middle initials. George H.W. Bush, which would refer to the older of the Bushes, whereas George W. Bush would be for the son. All right, the same type of issue is going to happen with chemical names and formulas. If for a given chemical name it could only correspond to one formula, then we tend to give it a very simple name. But if a given name could possibly refer to two separate chemical formulas, we have to do something to that name so that you could distinguish between the two compounds. All right, and you'll see examples of how that works in just a second here. So we're going to start off with naming ionic compounds. All right, so there's a fairly straightforward method for doing this, which I'm just going to describe as saying that there's going to be always a first name and a last name. All right, the first name is going to be either the positive element that's in the formula or a polyatomic ion name, followed by the last word, which is either going to be the negative element "-ide", which is going to be a modified version of that element. And you'll be familiar with a lot of these terms, or the polyatomic ion name. All right, so I've given 4 examples of ionic compounds here that cover the 4 different combinations of these. All right, so let's start off with the first one, MgBr2. All right, and if you look at it, the first name is either going to be the positive element or the polyatomic ion name of the positive ion that's within that formula. All right, so luckily, whenever we do ionic compounds, you always put the positive ion first. So the first name is going to correspond to this right here. All right, and you can see that that is magnesium, and that is what's going to be the first name in its overall name. All right, we said that the last name is going to either be the negative element "-ide", you see dash "-ide", or a polyatomic ion name. So what are the negative ions in this formula? It's bromide ion, or Br-1 ion. All right, so what we do is we take the word bromine, and instead of saying bromine, we take off the last 3 letters and we substitute them with IDE, and you say bromide. All right, so the name of this right here is magnesium bromide. All right, moving to the second compound, it's similar to the first, except for the negative ion in this formula is actually a polyatomic ion, right, which is this right here. And the list for all of the polyatomic ions, along with their formulas, names, and charges, can be found in this section on page 7 in your reference guide. All right. So, and if you look at that little list, you would see SO4, which has a -2 charge. And then the name for that polyatomic ion is sulfate. All right. So in this case, first we need to look at what is the positive ion in this formula. All right. That's going to be sodium. All right, so the first name of it is sodium. That would follow this part of the rule. All right, and then the second word is going to either be the negative element iod or the polyatomic ion name. All right, notice here, in this case, the negative thing is a polyatomic ion. So we're just going to use the name of that polyatomic ion. Right, and again, you can get the name of that polyatomic ion from that list, and its name is sulfate. All right, so the name of this ionic compound here is sodium sulfate. All right. In the next example, this is going to be essentially a reverse of this compound, where the positive thing in this formula is a polyatomic ion, and the negative thing is a monatomic ion. All right. So if you look up NH4, you would see that that's the very first polyatomic ion in this list. So again, since the positive thing is a polyatomic ion, you give the name of that polyatomic ion, all right, such as described here. So that is ammonium. And then, since the negative thing is a monatomic ion, you give the "-ide" version of that element. And the last possible way that you can name this would be if the first, both the positive thing and the negative thing are both polyatomic ions. All right. So if I were to look at this formula right here, the positive ion is going to be NH4 or NH4 plus. All right, and that is ammonium. All right. The negative thing is going to be SO3, which has a -2 charge, and the name of that is sulfite. So the name of this guy is sodium sulfite. So far, all of the compounds that we've given names for have been ionic compounds. All right, we're going to move on to naming covalent compounds. All right, and so first of all, what's one of the ways that you can tell whether a compound is ionic or covalent by its formula? All right, well, this is a little bit oversimplified, but one quick way is that if it's all nonmetals, it's going to be covalent. But if it's ionic, it's going to have a metal and a nonmetal. All right, so or a metal and a couple of nonmetals. All right, and you'll see examples of these in just a second. All right, so a problem would arise when you're trying to name covalent compounds because the same atoms can combine in multiple ratios. All right, so whenever we named ionic compounds, notice that there's nothing about the name, just reading the name, that would tell you how many of the different atoms there are. For example, if I were to name MgCl2, its name would just be magnesium chloride. All right. So how do we know what the formula is if this is its name? And the reason for that is that there's only one combination of ions that would give a compound, which was between magnesium and chloride. All right. And if you go back to it, remember this has got a +2 charge, and the chlorides have minus charges or -1 charges. So you need to have a 1:2 ratio between these atoms. All right. Another way of saying that is MgCl doesn't exist. All right. So because there's only one possible combination of ions, if you name it as magnesium chloride, someone could very easily figure out that this is the formula that you're talking about. All right. But the same situation does not exist for covalent compounds. For example, it's possible that these two compounds right here could both exist. This would be NS3, this is N2S5. And if we were to name these compounds the exact same way that we named ionic compounds, we would just call it nitrogen sulfide. All right, but here's the problem. If we were to call this nitrogen sulfide, could you tell which of these we were talking about? And the answer is no, because there's multiple compounds that would be combinations of nitrogen and sulfur. All right, so to get around this, whenever you're naming covalent compounds, because there are multiple ratios possible, you have to add prefixes before the names in order to specify how many atoms there are. All right, so for example, NS3 would be nitrogen trisulfide. All right, N2S5 would be dinitrogen pentasulfide. All right, where we do part of it the same as what we did before. Notice that the base word of the first word is just the name of an element. The base word of the second word is the "ide" version of the element, but then we occasionally put prefixes in front of those to signify how many of that particular element there are. All right. So one thing that you're going to have to learn to do when applying this method is to memorize some prefixes. All right. So for 1, the prefix is mono. For 2, it's di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. 10 is deca. And so there are additional prefixes, but we're going to limit this to 10. All right. And some of these should be excuse me, a little familiar. So for example, an octagon, people know that as something having to do with 8. All right. So make sure that you've memorized these. And just a quick example of how they would be used. If we had P2I5, all right. And so first of all, how would we know it's ionic? Or sorry, how would we know that it's covalent? Well, both phosphorus and iodine are both nonmetals. All right. They are both in the nonmetal portion of the periodic table over here. All right, so that tells us that it's covalent, and so that tells us that when we name it, we're going to have to include the prefixes that tell you how many of those atoms there are. All right. The thing about this is, as long as there's multiple atoms of both, you just add the prefixes. It can get a little complicated because there's some modifications to the rules in certain situations. All right, and the first of these modifications is in how you use the prefix mono. All right, so mono again is the prefix for 1. All right, so when you do that, so the thing is, if there's only one atom of the first element in the name, you don't put mono. All right, and a classic example of that is something that we're very familiar with, which is CO2. All right, the name for that is carbon dioxide. Notice that it's not monocarbon dioxide, and that's because the thing that you have a single atom of is the first element that's mentioned, or the first atom that's mentioned in the formula. All right. If, however, the second element you only had one of, such as CS, we would then need the mono for that. All right, so CS would be carbon monosulfide. All right, you don't need it for the first one, you do need it for the second one. All right, a common example of this is the chemical CO, which is carbon monoxide. All right, which has another little modification to the rule, which we'll talk about in just one second. All right, note, if I give you, a lot of times when we're going through this and I get people used to this rule and I show them something like NaCl, all right, and ask them to name it. All right, sometimes people will say, well, that's sodium monochloride. And what they forget is that before you name it, you have to recall, is this an ionic or covalent compound? All right, NaCl is ionic, which doesn't use any prefixes at all. So this is just plain old sodium chloride. All right. The one other little modification to this rule has to do with how you use mono. All right, and that is whenever you actually it's not mono, but how you put some of the prefixes in front of oxide. All right, and essentially this is just a way to make these sound a little bit easier. Instead of saying monooxide, we say monoxide. All right, instead of saying tetraoxide, where we repeat that vowel sound twice, we drop that first vowel sound and we just say tetroxide. All right, tri plus oxide, however, you don't do that. You would say trioxide. All right, mono plus iodide is monoiodide, and tri plus iodide is triiodide. So for these examples, whether it ends in an O or an A, you drop that vowel.